Okay, today we are going to talk about parametric equations. We've done a little bit with these before, but we're going to be specifically graphing them. And parametric equations have two parts. They have an x, actually they kind of have three. They have a y, and then they have some boundaries on t. T is my independent variable, but it's not going to show up on my graph. So I'm going to end up graphing x versus y, and I'm going to make here a t, x, y table. I'm going to pick all my t's. I'm just going to go by whole number or integers here between -2 and 3 because that's my boundaries on t. I will plug them in, get -4 plus 1 is -3, -1, 1, 3, 5, and 7. I plug in t for the y. I get 4 minus 7 is -3. 1 minus 7 is -6. -7. 1 minus 7 is -6, -3, and +2. So if I graph this, I just graph x versus y. Again, I am not interested in any way, shape, or form as to what is t. T is not going to show up on this graph. So this here is a part of a parabola. If I wanted to write the rectangular equation, that's a popular question. So write the rectangular, that's the standard equation. Options for doing this are solve, usually probably easiest to solve the x equation for t. Not always easiest to do that. Sometimes you'll do it the other way. If they give you y equals t, I'd just plug in y for t. But here I've got x minus 1 over 2 is equal to t. So I can do this. I can kind of square top and bottom. So squaring the bottom is getting a 4 on the bottom. I'm going to pull that in front as a 1/4. X minus 1 squared. And I'll just leave it like that. That's an equation I'm kind of used to. Shifted right 1, vertex is -7. 1/4 is my a value. Okay. That's basic parametric equations. Rectangular form is this. I probably should define my x's go from -3 to 7. Parametric form is this over here. Well, we can also graph some of our conic sections in parametric form. We have the circle, which we know in parametric form, that's just x equals r cosine t, and y equals r sine t. If I want to adjust for h and k, and this will apply to all the rest of the conics too, I simply so notice they were opposite sign before. They are the same sign here. I just simply tag them on the end with plus h or plus k because I'm just adding or subtracting. depending on which way I'm going, from the y coordinate. So my ellipse, and I'm just going to ignore for now, these are all in your packet, these conversions, although I don't think I have referenced in there the area R and Y. For this one, A is usually the bigger one, so this technically could be B cosine T, A sine T. A is the bigger one for finding where C is. The key though is the X direction on the ellipse has to go with the cosine, the X, the Y direction goes with the sine. On a hyperbola, again, this really about is what's with the X goes with the secant here. Oops, I want that to say B tangent T. And those are my conversions. So let's say I give you this. So I know here this, actually, I know this is horizontal. This one, it matters. I know this is x squared minus 9 over y squared minus 49 equals 1. That's my rectangular coordinates. For the other version of the hyperbola with the y squared first, so a vertical one, we flip the tangent and the secant. And whatever is with x stays with x. Okay, so that becomes important to classify which one. So that is a little bit of an introduction of parametric equations.